Hi, in this video I'm going to explain to expand the concept of the antiderivatives with many more cases than the ones we have only seen. So I'm going to start using this diagram, on the left. In a sense, if you have an f of x, you take its derivative, well, you get to ef prime. And if you take the antiderivative of this f prime, you will get back to the f of x. So let's use that to our advantage. And well, let's see, I'm going to make the first example here. Suppose let's start with something very simple. You have a sine of theta. If you take its derivative, would be the derivative of sine of theta would be cosine of theta. So now if I take the antiderivative, following up this diagram as a reference, if I take the antiderivative, let's write like this, antiderivative of cosine theta d theta, this would be equal to sine of theta. Well, of course, in this case would be a plus c. The thing is, if you take the antiderivative of this expression, you will get back as well to this part that is where you started. So let's try to use this with another example. Suppose we have something that you might have figured out by now. Let's say the antiderivative, the derivative of the natural log of x. In this case, this derivative would be 1 over x. So if you take the antiderivative, the antiderivative of 1 over x dx, this would be equal to the natural log of x plus c. But now, there's something missing here. This expression with this natural log of x, there's something we have to add. But I'm going to explain it later on. I'm trying to make it simple and just to explain the first cases. So let's continue with another case. Suppose we have, let's see, I'm going to take the antiderivative of cosine of theta. The derivative of cosine of theta. So this would be minus sine of theta. So if I take the antiderivative of minus sine of theta, the theta, this of course would be equal to cosine of theta plus c. But now let's change it a bit. Suppose we have now the antiderivative of sine of theta d theta. So what would this be equal to? We are missing out this negative sign here. So, well, in a sense, I'm going to explain it with a reference. Suppose if you have a function f of x, now if you multiply this f of x times -1, of course it will be different than the actual f of x. But if you multiply it times -1 times -1, this is just the same as saying you're multiplying this f of x equal to 1. So this would be equal to f of x. You're not changing anything. So I can do this minus sign, and I can put a negative sign outside of the antiderivative. So in this case, we know what's the answer for this antiderivative. It would be cosine of theta, but we have this negative sign outside of this antiderivative. So the result will be, in this case, minus cosine of theta plus c. Now this is a lot of steps, but the thing is, it's sometimes very clear that what's going to be the answer when it's something very simple. So some simple cases. So let's see. Let's work through another example. I'm going to work on another example. Suppose you have now the antiderivative. I want to take the derivative of e to the 3 times x. This derivative will be equal to 3 times e to the 3 times x. So if I would ask you to do this, the antiderivative of e to the 3 times x dx. Now the thing is, we will be missing out this 3 that's multiplying the derivative. So we are lacking here something. So what we can do here, we can use another principle such as this one. So again, if you let's say if you take a function f of x and you multiply times 1, this is still f of x. So I can do this. I can multiply this expression by 3 over 3. Now this is equal to 1. So another thing is 3 over 3, we can play around with this expression. If I do this, 1/3 times 3, this is still 1. But the thing is, we know that this expression, we know its solution. This would be equal to e to the 3 times x. But the thing is, we have this 1 over 3 that's multiplying this expression. So we have to consider it in the result. So at the end, this would be equal to 1/3 times e to the 3 times x plus c. Well, I believe you can just figure out what's going to be the answer for these very simple cases. If you not so sure, you can use these intermediate steps. Now I'm going to show you how to solve this last example, this one, in a different way in the next video. So let's get to it.